One of the biggest issues facing us as broadacre farmers of recent times is the drift of agricultural chemicals onto susceptible crops, but also into urban areas. Environmentally, we're dropping some chemicals into resources like our rivers and streams. We're all familiar with direct drift, and that's when we spray along a fence line and we get drift over into the adjoining paddock. There is another type of drift, and that's the drift that goes over many, many kilometres, and it has been reported drift as a result of inversion layer conditions can go for 100 kilometres. It is not as predictable as we'd like to think about where it goes, because inversions chop and change in terms of the direction of the air movement. What's happening is we are producing droplets that are prone to drift, and then we're getting the conditions that make them drift. And the way that occurs is when we have travelling at high speeds. And when we travel at high speeds, it simply means the droplet has further to go in the air. And if it has further to go, it has more chance of drifting. But even while it's travelling, it's getting smaller. And as it's getting smaller, it's going to be picked up into the atmosphere and move off with an inversion layer. So speed is a big issue. Another one is height off the ground. When we actually have the boom higher than 50 centimetres, then gravity's still taking effect from the 20 centimetres, and we might be trying to float through 2 metres or a metre of air to get to the target. And the droplet's evaporating all that way, so it's either going to drift off or certainly not going to reach its target. Really, the two most important things are speed and height of the boom. The third is the flicking on the ends of the boom. As a boom, the wider the boom, the more it flicks as it traverses at the end of the boom. Well, that throws droplets high into the air, and every time that happens, there's more droplets being thrown into the air that cause a problem. The fourth issue is the droplet size itself. Medium droplets become small droplets with evaporation pretty quickly, and a medium droplet on its own is quite prone to drift. When we do use very coarse to extra coarse droplets, we are very confident that we can reach the target, we can get very good weed control, and we can go out and spray during the day. From what I've seen, inversion layers occur in the mid-north of South Australia on an average of 5 out of 7 evenings, nights and mornings during the summer month. Just about every day we could say we're going to get an inversion layer, unless of course there's a continuous breeze over 11 kilometres an hour or full cloud cover. The code of practice, that is a statewide code of practice, says not to spray within an hour and a half prior to sunset through to an hour and a half after sunrise, unless there is no inversion layer. So if there's full cloud cover at night, there's a breeze continually over 11 kilometres an hour, feel comfortable about spraying in those conditions. But as we're getting into the afternoon and we're seeing the wind starting to drop out, we're pretty sure that there's going to be an inversion layer. It's time to stop. Don't be afraid of those temperatures that perhaps we used to be afraid of. Don't be afraid of spraying during the day. Let's make sure that we produce droplet sizes, we maintain operating speeds less than 18 kilometres an hour for our summer spraying, because the downside of all this is, unfortunately, is losing products. And I don't think any of us want to lose the products that are so valuable to us for spraying in spring, summer and early autumn. So let's just keep our herbicides in our own paddock. It's not that difficult. We're pretty sure that we can solve this problem of the harm that we're causing to others.